Yeah, so for this presentation, the agenda that I covered is I will take you through a brief field overview of Goliat. And after that, we can get into the Retrofit MLT implementation on Goliat, where I will cover the technology itself that we have implemented and a brief sequence of operations for people who have never seen this before, or for them for whom it's new. And then I will try to cover the drilling and completion success factors that sort of enabled us to perform these complicated operations. And then at the end, I will try to cover the opportunities and learnings from our journey planning the retrofit MLT wells. So Goliat field, it's located in the offshore. It's an offshore field located around 85 kilometers northwest of Hammerfest. So that's quite up in the north, as you can see. It's sort of the fields that are nearby are producing fields that are nearby are Snøhvit and Johan Castberg, soon to be up for production. So it's way up in the north, the Barents area. The license basically was awarded in 1997, and then of course the operators is Vår Energi, and we have Equinor as a joint venture partner with 35% share. The discovery was made in the year 2000, and the production startup has been in March 2016, sorry. The water depth is around between 320 to 420 meters, and it's mainly, the reservoir is mainly producing oil as of now, although as time passes, is more of gas coming, but it's difficult to handle a lot of gas in on the FPSO. So we have to choke back some of the wells, but mainly it is set up for producing oil. There are 3 reservoirs, stacked reservoirs in the field, Goliat field, mainly called Realgunan, Snad, and Kobe. And yeah, we have a STOIP of around 572 million barrels, and total production so far as around 127 million barrels, which is giving us a recovery factor of around 22%. And the drainage strategy is void replacement with gas and water injection. It's just a very cool picture to show about the field overview. So as you can see, I mentioned about the stacked reservoirs here. So the first one that you encounter is Realgunan. We have 6 oil producers there, 4 water injectors and 1 gas injector. And then below that comes the Snad formation. That's it's 1 oil producer and 1 water injector there. And then below the Snad comes the Kobe formation, that is having 9 oil producers, 4 water injectors, and 2 gas injectors. So the field itself, as you can see with the stacked reservoir, it creates a bit of challenge with regards to achieving the with regards to the well integrity part of designing these wells, especially when you're drilling when you are completing a well in Kobe. You need to make sure you isolate all these reservoirs above, so that creates an additional challenge. Yeah. So just a bit regarding the background of so the first job, of course, was done in 2017. Sorry, 2020, around 2020. the first retrofit MLT job was done. And at that time, it was the first worldwide application subsea that enabled us to get, as you can see, place in the news. So it was quite a proud achievement at that time. And, why exactly are we doing this? It's as when it comes to Goliat field itself, all the well slots have been producing. All the oil producer slots have been producing. What that means is that if we want to increase the production from the field, then we would either have to have a high capex of installing a template with more slots and subsea infrastructure, and that probably will not work the best when it comes to economics. And then when we actually implement or use the retrofit MLT concept, it saves a lot of money and giving very good production and drainage from the reservoir. One advantage that Goliat has, of course, is that we have the horizontal Christmas tree that also enables us to do this operation in a more cheap manner, because if we have a vertical Christmas tree, you end up you will have to pull the tree before you do anything and then install it again. But in case of horizontal Christmas tree, all this operation is done with the tree on the wellhead. So it makes it cost-wise, it is becomes much easier. Yeah, so it gives us access to undrained oil volumes in the vicinity of the nearby single bore producers. And so far we have around 4 retrofit completed from 2021 to 2024. And we believe that it's one of the values of War Energy to challenge the entrepreneurial mindset. So it's something that that has been done for the first time and has been a success and has contributed immensely to the Goliat field. And efficient collaboration has been a key with regards to the vendors. This is it's very complicated operation and requires very good collaboration with the vendor who is supplying the retrofit MLT. And we had a very high focus on risk management during the planning phase, especially with regards to choosing the window depth and the well integrity related aspects. And of course, it was a very high, good collaboration with regard with the subsurface and the drilling and well departments. So the history so far, we have drilled 4 retrofit MLT, 1 in Snad, 1 in Real Gunal, and 2 in Kobbe. And we already see the results. Basically, it's first incremental production increase of 1 to 4 barrels of oil equivalent per well. So it's quite a good increment, and the payback time is approximately 6 to 14 months. And significant lower cost compared to new infrastructure. So it's quite clear the reason for having this retrofit MLT. And so far it has been quite a big success story for Goliat. So that was just a brief overview of the Goliat field. If anybody has any questions, you can before I move into the MLT technology, we can take it now, or we can also take it later. No problem. So then, the typical completion on Goliat, we have the lower completion that consists of a nav issue to help us guide the completions down to TD, and then we have the screens, standalone screens. We have an FS2 barrier valve that creates a barrier envelope during operations. And then this is hung on a screen hanger. And then for the upper completion, we have a production packer, which is hydrostatic set, chemical injection valve, downhole pressure temperature gauge, and we have the TRSV, or the downhole safety valve. And this is all, and the upper completion is mainly 5.5-inch tubing. So when we go on onto the well, normally, and we want to make a retrofit MLT well, then we are basically performing a live well intervention in the mother bore. In the main bore, as you can see, the yellow part is the existing bore. We set a plug into the mother bore, and then we cut the tubing in the upper completion and retrieve the tubing and perform the retrofit MLT operations. Basically, is by installing an anchor packer, a junction, performing the sidetrack, and drilling the well, completing the lateral section by installing screens, and then installing an upper completion with the zonal isolation, which gives us complete zonal control of both the lateral as well as the main bore. So I can just go very quickly through the sequence of operations that we do. This is going to be very retrofit MLT specific, so it's not covering the part where we do the live well intervention to temporary P&A, the main bore. So here in the main bore, if we are starting from the point where the main bore has been temporary P&A'd with a plug, and the completion has been retrieved. So the first thing that we will do is after that we are going to go down, and we are to perform a cleanup run and tag the upper completion just to get a depth reference. It's very important to get this depth reference, because it sort of decides going upwards where all your other components are going to land. And at the same time, the objective also of this cleanup run is to relog the casing collars. So most of the times, this is seen as it's not an absolute necessity if you have complete trust in the log that has been performed earlier, and you have an idea about the collars. But of course, the log is performed with wireline, and then you are going to be doing this with drill pipe, and then there's some other uncertainties about the tally, which we are not sometimes. So if there is a bit of a concern there, then it's always good to include the possibility to log the casing collars, because by that we ensure that we are milling in the correct depth when we drill through the window. And then after that, we install an anchor packer. This anchor packer is basically something that forms the fundament of the retrofit MLT job. So this anchors the junction that comes later on. It anchors everything into place, and also forms the base of your depth so the space out of this anchor packer is very important, and that's why when we have logged the casing collars and everything, we know exactly where we are going to place it. We know where we want to mill the window, so we set this anchor packer accordingly. And below this anchor packer, we have some tubing and an overshot that helps us connect to the, or at least engage the tubing cut that was made on the completion. We install this anchor packer with the running tool, and on Goliat we have done something. Normally we used to have a uh, we used to have a dedicated run to perform to record the orientation of this anchor packer. But of late, we have included a slim MWD that as a part of the running tool that with an IBV that enables us to set the packer as well as to perform the MWD. So that saves us one run. Yeah, it's quite cool. And then we set the packer and perform the test on this packer. And then after that, we perform we do the sidetrack. Basically, we install the whip stock. This whip stock is based on when we get the orientation of the anchor packer, we can set the bottom of the whip stock to make sure that it is aligned to latch onto the anchor packer in the correct way. And in addition, we also have an MWD included in this BHA to make sure that we are correctly latched on. And then you shear the bolt from on the whipstock, and then you continue milling and mill the window. And then after that, we drill the 8.5-inch section all the way to TD. And displace the well to low solid oil based mud. That's the mud. That's the fluid low solid oil based completion fluid. That's the fluid we use basically to run the screens in. And then we install the screens. Basically, the screen is run with a drop-off liner, a drop-off liner at the top. And that basically we run in hole, and then we drop the liner. So here it is the risks are high because we need to make sure that we have a good hole, because there's not much play with regards to not being able to reach TD here. So we have to reach TD and have a certain rat hole to make sure that we are, because later on when we go and connect with the connector BHA, we need to make sure that we are at the correct depth. If we are not able to run in hole to TD, or if we are hanging up, if we are not able to run to TD, then the contingencies become very complicated. And then we fish the whipstock. We go down and fish the whipstock after we have installed the drop-off liner. And then we install the junction. This is basically an assembly that goes onto and latches onto the anchor, and as well as creates a window for the connector BHA to go inside and connect into the lateral PBR. And this is also oriented with the MWD. And then we run the connector BHA. Then we install the connector. This connector essentially is the one that goes into the lateral board through the junction, as you can see, and into the lateral PBR, and performs and makes a seal there. The running tool in the connector BHA enables us to test these seals after they have been engaged, and also test the seal that is formed between the connector and the junction. And then after that, we install the packer, and then this helps us close out the TAML 5 level basically. And then after this, we install the upper completion that goes inside this, and with the production packer, then we are having a full retrofit MLT well with complete isolation of zonal isolation of the motherboard and the lateral board, and you have full control in order to produce from either or both. Yes, if you have any questions regarding the sequence of operations or any question regarding how we must have done something, you can ask. Yes, Vito.
Hi, Namesh. No, I have a question with once you've installed this, what is the full bore ID, drift ID for the junction and everything? What's the restriction based on?
Once the upper completion is installed?
Yeah, and through the junction, right? Can we pull out the plug, or are you able to retrieve the plug through the?
Yes, good question, Vito. So the intervention capabilities is that we are able to access the main board with wireline, but we have a restriction of 2.6 inch. So basically, it's not a lot that we can do. The setup that we have with regards to zonal control is we have this valve that's installed in the through the production tubing, and basically that has to be retrieved in order to be able to access the main production tubing. But on the lateral side, there is no wireline access or mechanical access. And when it comes to the plug itself, this is something we cannot remove. We cannot retrieve because of the OD of the plug. So we have successfully used the ME plug with the IBV in our operations. And before that, we were using the Halliburton FS2 valve. We used to use a pump open. We used to use this ME plug with pump open sub as for the initial part of the operation, and then we used to pump open this plug prior to closing the FS2 in the anchor packer BHA. But we had some experiences that was not good in one of the wells, and so we attempted to use this one in the last well, and it was a successful operation that enabled us to save a lot of cost by not running an FS2, and it was a much simpler operation. Did I answer your question, Viro?
Yes, thanks a lot, Namesh. Appreciate it.
Thank you. Yeah. So then we can cover the success factors that enabled us to complete these wells. So from the drilling point of view, it's with regards to design, it's important to keep integrity in mind, especially keeping in focus the kickoff point selection. Because the exit point, first of all, it needs to be located in a competent formation, because as we could see, there is a few meters of after you've dropped the drop of liner, there's a few meters of overburden that is exposed for some days, and it's very critical that this risk is handled well and understood well, and the kickoff point is selected accordingly. The production casing, most of the times when we plan wells, we are always planning with the lowest cost possible. But what we see, of course, is that it always helps if one could actually, when we are planning a new well, think about the future possibilities. If there is a possibility to do a retrofit MLT and construct the well accordingly, because uh, what happens is that depending on your material compatibility, your production casing sometimes need to be 13 chrome, for example, or super 13 chrome, depending on thing. And then if you don't have, and most of the time when we construct the well, we just have a small part of the casing with that material where we set the production packer. But when we go on and to plan a retrofit MLT well, it can be a deal breaker when we don't have that material, enough of that material available to be able to set the production packer at that depth. So it helps to just have it in mind when we plan a new well to understand if there is possibilities of retrofit MLT. And then the fallback option is something that needs to be looked into. We need to have sufficient height. And when we talk about sufficient height, we need to have sufficient height with good integrity of cement and everything in order to be able to have a fallback option. So this, and then of course, all this, when you think about all these things, it normally ends up that you end up with a kickoff point quite deep, and then that creates some challenge with the well trajectory and the DLS, resulting DLS, and also future operations with regards to funding completions. But it's good to take these keep these things in mind while planning the kickoff point. And then for the zonal isolation, we need to have sufficient logged annulus cement above and below the window. This is very important. And opening the casing window means overburden formations that are normally not exposed will be in communication with it as well. So this is where I come to that point where we have, when on Goliat, we have these 3 stacked reservoirs, and especially when we go to the bottommost one and we are kicking, we make this kickoff, getting the integrity right with regards to, because we're relying on the old cement that is there and the log. And it's often very challenging to isolate all the flow zones, especially when we are planning for these wells. And then wellhead fatigue and casing wear, like any operations on an existing well, this, like I said, these were the, we have the horizontal Christmas trees. And one of the disadvantages of the horizontal Christmas trees, keeping aside the advantage for this retrofit MLT job, is that, the resulting wellhead fatigue due to operations is quite high, normally higher than a vertical Christmas tree. And that's also very important to get finalized in the early stages to make sure that you have enough life left on the wellhead in order to do the operations that you plan to do during a particular time of the year. And then when it comes to execution, and the whipstock selection, window milling, and whipstock retrieval, the torque limitation due to drilling latch is always there with regards to risk of turning and losing the MLT junction. And then, we had some problems with regards to being a bit too fast with regards to milling. It's not particular to this operation, but it's just something that we see. We were not taking the time in order to do to make the mill, especially over here with regard the tolerances and all are a bit more stringent, because of the retrofit MLT concept. And then we have the whipstock retrieval with hook. You can see how the condition of the whipstock looks like when we pull out of the hole, and it's extremely so you do lose a lot of parts of the whipstock, and in some cases it's also possible to lose the opportunity to pull the whipstock in the conventional way if you've damaged the pulling profile. And you can see these are from our wells, basically. You can see the parts that we have retrieved during the cleanup run after retrieving the whipstock. And then, yeah, so the failure to retrieve the whipstock is a major risk, of course, and all this risk is amplified because during this time the overburden is exposed. So like kind of time, these are operations where you need to be quick, and then of course if a risk hits you, then you are running against time. Okay, and then yes, Phillips.
Yeah, good morning. I was wondering where you've got there about the clean out for with the whipstock. Was that a dedicated trip there to clean out after
Yes.
after milling the window? Yeah.
Yes. Yes,
Okay.
we highly recommend that, a dedicated clean out, although it takes extra time, but it's extremely important because after this operation, you are going to go and latch onto the anchor packer, and at that time, if there's debris in the anchor packer, you will struggle to latch, and it will have an impact on all operations going forward from there.
Okay. Yeah, great. Thanks.
Yeah.
Namesh, can I add one comment to this question, because it's very good question, and I just wanted to add.
Here. I did not know that, but it's amazing. So, guys, just to introduce Antonio, he has been the pioneer or planner of most of these initial retrofit MLTs, right? Yeah.
Yes,
so
yes.
Please say something, Antonio, if you have.
No, it's just a quick add-on that might be relatable for many other asset and fields. One of the most delicate operation was exactly this extra clean out run is needed, but it's important to frame correctly the parameters because you have now exposed lateral bore. And of course, you need to try to mill the window and start the lateral in a competent formation, but most of the time it's not that simple. You might have inconsolidated sand or some shale that are not so stable. So you need to think about the whole process. Right now, you need to drill the whole well, come back, do all the displacement, the drop-off liner, and then eventually the last operation, it will be the installation of the junction and the connector to cover that little 5 to 10 meters space of formation drilled. So it's important that also the parameters are good enough to ensure good cleaning, but also not disturb the formation in a way that you might create instabilities. And we have seen these kind of issues. We were really in a tight spot there, but we managed to. So it's important to do it. So it must be done, but it must be done with the right parameters because of interfaces with the new drill formation.
Absolutely. So it is. Yes, so it's time.
Yeah, just a follow-up question. Is it a major risk or is it a low risk with a major consequence? Because I guess this whipstock exercise and drilling out through a casing has been done on Troll for the last 10 years with fishing out the whipstock where you convert it into this expandable liner solution that they had there, converting this to a new MLT well. So I was just wondering if is it a major risk or is it just a low risk and a major consequence, basically? How do you, with respect to the failure to retrieve whipstock, because it's gonna be done for, as I mentioned, at least 10 years. Well, more or less every well they have.
Yes, it is quite it's quite a common operation, I think, like you were saying, and there have been some experiences, I think, but at least we have not struggled with that on Goliat so far. But what we have struggled with is with the cleanup runs that we have performed afterwards. They have not been the best, and then we struggle to latch on with the junction BHA. And at the same time, it depends on field to field experience. Like Antonio said, when we are doing these operations, we are going to subject the formation to different surge swap pressures, and it needs to be accounted for and risked in a proper manner with regards to doing it. So the parameters have to be really. We have done this a few times now on Goliat, so we have some experience, but I tend to agree with you that it's a low risk, high consequence part with regards to retrieving the whipstock.
Yeah,
At least based
thank
on
you.
our experience, yes.
Yep, thank you.
Yes, any questions about so the reservoir section drilling? What we have done, of course, is we clean hole while drilling just to make sure that to avoid any kind of back reaming or anything as such. And then, we've been drilling through a lot of different zones in the reservoir sections, depleted or overpressurized. So it's quite important to make sure. And it's as you can see in the chart here, you can see that we have the window is not that it's narrow at certain sections. So it's quite important to make sure that we understand those points and make sure that we are able to mitigate those risks with good operational procedures. Yes, so completion success factors, with regards to the well re-entry and pulling of the completion, we have, the early preparations is a bit important in this case. So we, of course, with regards to the global rise analysis and local wellhead analysis, we have to make sure that we have enough fatigue life on the wells, and of course install motion sensor or any kind of mitigation that need to be done in order to make sure that you don't exceed the fatigue life on the well. Since in our case on Goliat, we have to perform the live well intervention on these wells. Of course, they are retrofit MLT. Normally, some people would, or in some cases, you would be able to do pre-P&A with LVI, but of course these are producing wells, so we need to be able to produce them as long as we can prior to stopping production and doing this retrofit MLT job. So in that case, it's always beneficial to do the intervention part with the P&A intervention part with the rig. But that, of course, triggers, it's going to be a live well intervention, and it requires a lot of equipment to be mobilized and to perform this thing. So it's, of course, every rig, every time we change the rig, we need to perform, ensure that all the interfaces are checked and that we don't miss out on anything. Because if you miss out something, of course, it's going to be a big consequence. And then the workover riser preparation, that's important to make sure that you have the correct workover riser for the job, and also preservation of that. And then the suspension strategy. The mainboard temporary suspension strategy is quite important. And as I mentioned, we have changed that strategy over a period of time, where we initially had a had an FS2 valve, but now we have moved to just using a ME plug with an IBV. That seems to have worked quite well for us and saving time and cost. So when it comes to running the lower completion itself, we try to see that we reduce or limit the geosteering actions to 2 degrees per 13 meters, limited by tortuosity and open hole friction factor. This, of course, is just to increase our chances to getting to TD without any issues. And then the lower completion string also has been optimized. Of course, we need to install swell packers and packers in order to isolate the different seasons, but we always try to have a discussion with the subsurface to make sure that we don't go overboard on this because of course it needs to be we need to come to a number that is reasonable and not something that is overboard. And on Goliat, we have not really struggled getting down to TD most of the times, at least in our wells. So the practices that has been followed has been quite good. And then the centralizer on the screens, they were machined down from 8.25 to 7.5, to maintain screen standoff and increase clearance. And then we have originally Goliat was using 658 screens, but we moved to 5.5 inch screens. To this again to be able to get down to TD, improve our chances. And then we perform open hole caliper at junction location just to make sure that we have we have the good measurement of the open hole section, because it needs to, in order to make sure that there is sufficient where we install the liner tieback PBR liner PBR. Sorry, we need to make sure that we are able to enter into that with the connector. And if we end up installing this in a area where there is washout or something, we might struggle to enter into the. So it's important. And on top of that, we also make sure that we have also implemented now some ID measurements for other sections also, where it's important in order to get zonal isolation. But that's not very specific to retrofit MLD. And then junction installation, we need to make sure we have very good depth control. So we try to use the same landing string for tag run, anchor packer, template, and connector installation. It's quite important, as I mentioned when we were going through the sequence of operation. It's very critical to make sure that we have the correct space out, because these depths are very it's all very, very much planned and everything is set up accordingly. So if we are off with the depth, we will struggle. And then for the template run, we mentioned that we did a dedicated clean out run to clean the latch profile and junction area. Of course, keeping in mind the risks related to formation and overburden, so formation stability in the exposed overburden. But we see that it was quite, it's important for us to do, because we have ended up spending a bit of time because we did not do it properly in the last job. And then the connector run, we focus on the tool orientation, search for BCD loads, to make sure that we don't disturb the formation and cause problems with regards to wellbore stability, and that in turn will create problems with entering into the lateral PBR with the connector BHA. For the upper completion, the Odin flow control valves, there was an EFAT performed to ensure that the flow control valve functions and interfaces are compatible with the Goliat control systems. And the logic was programmed for Goliat CCR to be able to operate these valves. And the downhole gauge basically was changed from a regular, early on Goliat there was two tubing, I think it was two tubing gauges. But then with the retrofit MLT, we have a triple gauge, which sort of records the pressure in the main bore, in the production tubing, from the lateral side, and also below the LP valve on the tubing. So, but that it was a new. Well, it was the same supplier, but the compatibility needed to be checked with the DIU on the subsea system. Yes. So with this retrofit multilateral, the opportunities we see is that we add a new well branch while maintaining the main bore. It enables branch control to optimize production. It's an innovative solution to unlock reservoir potential and increase the recovery. And it has been very valuable for Goliat, at least, where we don't have many slots and would result in a very high capex if you want to drill new wells. And then we reach the targets in close vicinity of existing wells, and we find new additional drainage points without investing in new infrastructure, and we see accelerated time to market for new volumes at low cost. And the limitations, of course, is we learn that we need to initiate well trajectory feasibility at a very early stage, because we see that the focus needs to be at a very early stage to make sure that it's normally the case, but what we see is that maybe it's not very well understood regarding the risks and all that kind of stuff, and then it comes back to us. So that's why it requires a very proactive cross-functional collaboration. We have that, but of course, it's sometimes good to focus on that. It has limited well intervention possibilities in future, not possible to enter the new branch later. So we have had some issues on one of the wells in Goliat, where the lateral branch was producing a lot of gas, and basically it caused and like I mentioned, Goliat is not able to handle a lot of gas. And then we are not able to do too much in that situation, other than just closing the lateral bore. So there is no possibilities to do any wireline intervention on the lateral bore. Then we need to have the robust plan for temporary plug main bore during the drilling of the new branch, which I just touched upon with regards to. We find the IBV, the IBV concept quite robust, and it worked quite well for us. And then it requires a very good cement bond towards non-permeable formation, that kickoff point and above, to ensure well integrity requirements. We see in NORSOC that, of course, these with new things coming in, and especially when you can't qualify cement across permeable zones as barriers, then we, in Goliat at least, with our stacked reservoirs, find it very difficult to find the proper cement in the correct place. So these checks are very important to do at the beginning, to make sure that we are in the right path. Otherwise, it has if you find out late, it takes a lot of time to get back. And then, of course, there's a limitation with regards to accurately predicting the fluid interference in tubing during commingled production. So there is a study going on, or some work going on with regards to handling this, but right now it's very difficult to understand what is the contribution from the lateral part, what is the contribution from the main bore. And then with regards to the retrofit MLT itself, there was some junction design improvements that we have suggested. And I think there are other operators also probably have this suggestion, is to have the upper completion PBR installed below the anchor packer to isolate the template. And that anchor packer hydrostatically. I can just touch upon what I mean by the first part. Yeah. So if you look at this figure over here, the lower completion PBR, I mean the upper completion seals into a seal area in the junction, and when we actually pressure up to cycle the IBV or pressure up to cycle anything, all the force is actually going onto the junction from the bottom, and that creates a lot of upward lift on this one. So if your junction is normally the junction is latched onto this anchor packer, so there shouldn't be any force being transferred. But what we realize is that sometimes the overpull force that we apply in order to check that the junction is latched is not sufficient compared to how much pressure we are going to apply in order to operate or to sort of open the plug below. And it's even worse with the IBV. It's possible to have low pressures in order to open this, but with the FS2 you require even higher cycling pressure, so that creates even more load. So if you shift this seal further down into the anchor packer and run your upper completion and seal into that part, then you're basically all the force that you apply will be seen by the anchor packer, which is already anchored onto the casing. So that's a big, or that is one improvement that we will definitely go for in our next operations. Yeah, so that was and of course construct a well for future RMLT operations. So it's important that when we are constructing new wells, it's always good to check, that the material we are using, especially in the production casing, has sufficient, is enough for future retrofit MLT opportunities, if any. Yeah, so that was the end of my presentation.
Excellent. Thank you very much for a very interesting presentation and good interesting presentation. So if there are any questions from people attending, then just raise your hand and then get the question out. Yeah, we have one from Sturle.
Yes, Sturle Steines. A question related to the ME plug and the valve on that one. Do you have a contingency plan to open that valve if it doesn't open by cycling pressure?
Yes. So we are able to go down through. So of course, the plug itself is set up in different ways, right? So you either cycle it open, and then at the end of it, if you're not able to open it, then if you're not able to open it, then of course you need to be able to. If you're not able to open it, then you need to wait till it has an ultimate life where it will open by default. Either you wait for that, or if you will need to go down, pull this plug from the Odin LP valve and then go down with wireline and perforate or punch above the plug. So these completions have been set and punch above the plug in order to be able to establish production.
Okay, thank you.
Just a question, Ramesh. Would you be able to release and then park it deeper inside, or because you have something below that, isn't?
Yeah, that's also an option, of course. But we have this FS2. We have this. What do you call this? We have some. I mean, it's an option, but it's more easier to just punch above. But yes, it is an option below to release and run it down. But this is a horizontal section, so you have to tractor it down. Most of our wells are horizontal in the reservoir section, so you have to really tractor it down all the way.
Mm-hmm.
So it's easier to just go and punch above and establish production. And of course, we check with the reservoir just to make sure that the resulting TFA is sufficient and all that. So those checks we have to, of course, have to do.
We have a question from John as well.
Yes, hello, John Gilchrist here. Lovely presentation, really enjoyed it. I have a question around risk management in terms of, I guess, the planning phase. Specifically, how did you address the risk of not being able to get flow from the motherboard that you suspended to do the new lateral? Was that viewed as being, negligible chance or a high chance? Could you maybe talk to that risk?
It's a very good question. So the biggest risk, of course, of doing a retrofit MLT job is that you lose your motherboard if things go south, right? But in the worst case possible, when we plan the contingencies, at least our last case is that we perform a workover. We straddle the lateral and we perform a workover to get back to at least start of the main bore. So that risk is right at the top, of course, and we plan for contingencies, especially what we covered with regards to the window, the window location, having a backup option, not being able to run with the completion to TD, having options to cut, pull, straddle the window, and decide whether we want to go. We want to drill another one or just perform a workover. So all those risks are quite critical, and with regards to losing the main bore. But we plan for it, and we plan for the contingencies.
Yeah, and maybe just a very quick follow-up question. So, in terms of the system that you selected, the Schlumberger Rapid X Level 5, in terms of their history of that system, had they ever had a problem with re-entry of the motherboard that they shared with you?
Re-entry of the motherboard in what sense?
Sorry, in the sense that for other clients, it executed the job very well in terms of the well construction phase, but for some reason, did they ever have an experience where they knowingly didn't get any production from the original bore?
Not that I have heard about,
okay.
But I will take this question.
Yeah, I'm curious because I'm conscious of through the lens of the suppliers. Obviously, they're very focused on delivery of their system at the well site, and they might not get the full cycle feedback as in what did they produce from the original bore and what were the problems. BJS in a bigger discussion, but I'm just curious of your experiences working with this vendor.
That's true, but normally these decisions with regards to what we do in the main bore is taken by us, by the operator, of course.
Excellent.
So
yeah.
We are the ones who are deciding what kind of plug we are going to set. We are the ones who are going to decide what kind of contingency we have with regards to if we are not able to pull the plug or if we are not able to open the plug. the retrofit MLT supplier normally will. This is my opinion.
No, it's good.
But,
No, it's appreciate leadership, because I think quite often it's easy to blame the service company, but ultimately the operator is responsible for their actions.
Yeah.
Thank you. Nice
At
job.
least for this part.
Yeah.
Mhm.
Yeah. Thank you.
Yes. Goliat.
Yes.
All the champions are in this presentation, and I did not know about it. So,
Just
yeah,
a
Goliat.
question about this area outside of the window. How stable formation you have there? Is it a concern for Goliat or not? Like how do you decide where the window exit is supposed to be? And let's say if there is a stable formation that you can leave for 1 week because you're using drop-off system, right? So how far outside of the window that stable formation is basically?
Yeah, this is of course one of the major risks with the operation. So when we are building the trajectory, it's very important that we have a good well-bore stability plot, and we have all this information up front to make sure that and because the drilling the window is a few things, right? So the well-bore stability in that area, plus you need to have good cement in order to be able to make sure you are able to drill that window in that area. So it's like a few things that play into it. But on Goliat itself, with the strategies that we have implemented, we have not really struggled with the overburden collapse. On the last well, the overburden was exposed to almost 1 week, and it was fine. So I would say that we were a bit fortunate there, but there's no number I can show you, Bulat. But the main thing is to make sure we have good confidence over our well-bore stability plot, good confidence over the cement that we have in that region, and good parameters. When we don't rush and just have the good parameters to drill and ensure that we don't through our operational practices end up stressing the well, to make sure to sort of increase the surge and swab or that kind of stuff to disturb the formation.
Thank you.
Grete has a question.
Yeah, Grete Letzok from Harbour Energy. Maybe you touched upon it. Is there any estimation in percentage how much this lateral increased the production from these 4 wells? You have any estimate?
I know that it is it's a well-to-well comparison, but I don't have a flat number for you on that.
No,
But it's
okay.
quite I think it's if I was to give you a number, I think it was almost I mean, because the lateral contributes quite a bit. The last well that we did, I think it was almost I would say almost 40%.
Okay.
Yeah.
Yeah. Large contribution, at least.
It is definitely, because
Yeah.
it's a good contribution. But on Goliat, we are a bit. It's a field related thing, because on Goliat, because of the gas, we are not able to produce gas, so we have to choke the wells down, quite a bit. So in order to not be able to get the gas out. So it's a very subjective figure that with regards what I provide you is very specific to Goliat field, but it's on another field, if we did not have the limitation with regards to gas, we would be producing much more, and maybe the contribution would have been much more.
Mm-hmm.
Yeah, I had a follow-up question with regards to this as well. How much the contribution would be for the 2 branches, and what measurements you might implement to find out with regards to tracers or pressure readings? Or you mentioned that there was some gas production from one branch and that you seem to have interest of having more information about how much the contribution would be for the two branches. What work has been done there, or is there any plans of implementing more measurements, basically?
Yeah, it was a proposal from SLB with regards to carrying out a study in order to be able to get this information regarding the contribution from different zones. But we haven't really started anything yet.
Okay, so no physical measurements then. So it's more modeling purposes.
No, not yet.
Okay.
Antonio, I think.
Yes, more of a quick question, looking at the comparison between the initial strategy of the first two retrofit versus the last one that you guys have performed. Also to mitigate this risk of high gas production, did you guys install in the lateral also some sort of autonomous inflow control devices, or is because the first screens we ran down, it was simple standalone screens with premium mesh, but I think that maybe also a good system would be to have some autonomous devices there to have a bit more of zonal control. And I guess that to answer also to what Eric was asking, for now, the equipment or the readings or modeling is taken through the downhole gauges informations and pressure, because we have dual gauge above the packer and triple gauge with the snorkel sub below the production packer. So basically one is reading the inline inside the tubing that is coming from the main bore, and then the one with the snorkel is reading from the annulus valve, this Odin. So then we have, in theory, the pressure readings and temperature readings from the two selected zones, main bore and lateral, and that you, from this data, you kind of extrapolate a bit to a certain extent, but it's not an accurate type of thing yet. But yes, I was curious about if in the last well, Namesh, you installed some solutions to kind of.
In the past two wells, we have installed screens with AICDs. But the last well that we did, that has been very good, producing good oil. But the one that we did before, that was producing a lot of gas, but that was because, I mean, it did not have the AICDs, number one. And the second one was because we believe that there's a gas cap, right, in this well. And we believe that the zonal isolation was not properly set up. So the packers did not swell, and then it was producing a lot of gas. So the last well that we did, Antonio, we have used AICDs, and we did a lot of precautions with regards to ensuring that we set the packers at the proper place. So and then that well was producing mainly oil. So it was good learnings from the incident and the implementation. So.
Okay, thank you.
Espen?
Hi, I just Espen Eriksen here, Aker BP now, but I used to be on Goliat, so I see at least one familiar face there, Antonio. So I could comment a little bit about the rate and how the laterals perform. Obviously, we would clean up the laterals one at a time and get a rate estimate for the new laterals. So you, by common downhole pressure afterwards, you'll kind of have an estimate for what each lateral produced. What's a particular challenge there as well is that hopefully you've drilled a new lateral into a slightly higher pressure reservoir as well. So you have to pay a bit more attention to the choking on your ICV on the Odin valves, because you will potentially rely a bit more on them to balance the inflow from each lateral than you normally would do. We tend to often just leave both valves fully open and produce them when you have a virgin multilateral, but here you potentially can have a large pressure difference. On Goliat, there has been good pressure maintenance, so that it wasn't automatically a problem, but we did have, as you see, a challenge with more gas from one lateral than compared to the other lateral, which created quite a need for choking one lateral compared to the other. And it's not always you can get the resolution on the way the valves are stacked, whether you have a shrouded or the unshrouded valve has slightly different characteristics as well. So yeah, so we do have or they do have an idea what each lateral produces when they're commingled production based on the cleanup strategies, and we can always close one lateral and flow test it at a later stage. So short comment there.
Yeah.
And I think actually we were down to push. We did actually do an intervention and open the lower plug in one Odin valve and went into the mother bore and shifted the IBV that closed on them during production once. So they have been into the mother bore as well through one of these laterals, which was successfully done as well. So we've used all the capabilities of access, I think.
Yeah,
So
that was,
performed very well.
Yeah, that was a well before, one well before the last one, where the FS2 just closed in during production, and then there was an intervention job done in order to be able to open that FS2. But yeah, and the reasons exactly why that happened is still very unclear. It was very strange behavior for the FS2, which is normally quite a robust valve. Yeah, thank you, Espen.
Okay, any more questions? No, seems like we have got all the questions at this stage. Now we got one more from Pavel.
Hi, Pavel from Equinor. Considering you've mentioned that producing from different reservoirs, so was there any incompatibility, water incompatibility issue was raised after that, or have you seen any problems with that? I'm not expert in this field, so I'm just wondering, because when I see laterals from two different reservoirs, the kind of first question whether you can mix from the production chemistry point of view, whether you can mix waters and whether you anticipate any problems down in the line.
No, maybe I've been on Goliat at least, but Antonio, maybe you can correct me if I'm wrong for the previous wells, but at least so far the lateral has been in the same reservoir. I mean, it's just that it is stacked, of course, but the laterals in whichever wells we have gone into and performed the multilateral, it has been in the same reservoir.
Okay.
Yeah, so
Yeah,
it's just that we pass through different reservoirs when we are so it creates a challenge with the integrity and isolating those reservoirs in the well.
Yeah, cool. Thank you.
Okay, I think maybe we can start closing this session then. So many thanks for a really good and interesting presentation and good questions afterwards. So the presentation here is recorded, so we will put it out on the network. We will also generate a forum page for this, where we can follow up with potential questions and answers for this presentation as well.